Alright guys, here we are. What you did yesterday, we took this section actually from yesterday and broke it into two parts. We did multiplication yesterday, and the things you hopefully mastered in multiplication yesterday, you're going to use those in dividing radicals, believe it or not. So there's a couple things I want to go over. First thing is this sort of old school rule about denominators. There's a rule that you can never leave a radical in the denominator. So like you could never leave this as a simplified answer. It's a rule that goes way back to the days when these things didn't exist, and I really mean like no calculators, and dividing by a mad crazy decimal like the square root of 6, whatever the heck that decimal is, would be incredibly difficult. If you think of long division and what you have to do to long division, long division is not the most fun thing in the world. If you do, to give you an example, 2, can you see that? 2 divided by 10, that's not too bad. But if you took the number outside and made it something like this, hopefully you can see that, it'd be incredibly difficult because all these decimals would have to go into here, which means you'd have to add a ton of decimal places here. So you'd never want to have a crazy decimal in the denominator. So this is a rule that hopefully within your generation will disappear, and I won't have to teach it in math class anymore. But currently it's a rule. You're going to see it on SATs sometimes. You're going to see it in certainly Algebra 2 a lot, and you'll see it now in geometry next year. So first rule, you can't leave radical in the denominator. It did come up a couple weeks ago with Mr. Snyder. He kind of taught this. I just want to make sure I re-emphasize it because I have a little extra time between now and the end of the year. The second concept is you can't leave fractions in a radical. We'll come to that later. So what I want you to do is think about how would you remove a radical from the denominator. In other words, how would you get this rad 6 out of the bottom? And it comes directly from something you did yesterday quite a bit. It comes from multiplication. Think about what you could multiply that by to get it to go away. And think about another concept as well. Think about what the square root of anything divided by the square root of itself would be. So from yesterday, we realized you can multiply rad 6 by rad 6 to get that radical to cancel out. So if you were to multiply the bottom of this by rad 6, there would no longer be a radical in the bottom, and this stupid division problem that old people from years and years ago hated to do would be gone. You wouldn't have to do it. You'd have 6 in the bottom instead of rad 6. But kind of like how you balance equations, if you multiply the bottom by rad 6, you also would have to multiply the top by rad 6. Because you don't want to change the overall value of this fraction, which is what I've got here. So you want to multiply this whole entire thing basically by the same thing. Multiply the top and the bottom by the same thing and it won't change. Just like if you think of like 1/2 as a fraction. If you multiply the top by 3 and the bottom by 3, you'd get 3 over 6. And it would still be 1/2. 3 is still half of 6. We're just doing that same idea with radicals. So you should understand that rad 5 over rad 5 is just 1. We're going to multiply this by 1. That doesn't look anything like 1. That looks like a mess. But you're going to multiply the top and the bottom by rad 6, which is basically just multiplying this by 1. So that it doesn't change its value, it just changes what it looks like. So rad 7 times rad 6, you know how to do that from yesterday, is rad 42. And of course the whole point on the bottom, rad 6 times rad 6 is rad 36, but we already know that rad 36 is really just 6. So your simplified answer, or radical in simplest form, for this is rad 42 over 6. Do you believe me? If you don't, take out a calculator, do rad 7, get a decimal, and divide that by rad 6, which is another decimal, and whatever that decimal is, it is equal to the square root of 42 divided by 6. Guaranteed every time, unless you type the numbers in wrong. That is a true statement. Why is this simplified? Again, we don't want to leave radicals in the denominator. It's a math rule. I'm not a huge fan of it, but you're going to have to know it for other math classes. So that's why I teach it. Bottom question on there is when you rationalize a denominator, which is what this process is. In other words, you make a denominator, get it from being an irrational number to a rational number, a number that's not a crazy, mad decimal. You're actually multiplying by a messy version of what? In other words, this rad 6 over rad 6 is really just a messy version of 1. It's really just this. And of course, the reason you're doing that, think about that for a second. This is a very good time to pause and answer this question why in your own words. I don't even know if I'm going to put them in my own words up here. Think about why you're multiplying this by 1. And I've already said it a couple times. And of course, the reason is when you multiply anything times 1, you get anything. You get the same thing. It might look different, but really it's equivalent. So if you multiply your happiness times 1, you get your happiness. Your happiness might look different because rad 1 looks a little different on here, but it's still the same value. So the idea is you don't want to change the value. You just want to change what it looks like. So give this this new rule a try. It's not totally new because you did see this a few weeks ago, but give it a try. Find each quotient. And it does have you say in your paper what's a quotient. You should certainly know what a quotient is from your previous math classes. Quotient, of course, is the result of division, just like the sum is the result of addition. So quotient is the result of dividing. So do rad 6 divided by rad 2 and see what you get. And I will tell you, some of these problems you're going to see are easy. Dividing radicals is not always complicated. This one is really easy. Just think of what 6 divided by 2 is. Well, duh, that's 3. It's just that the whole thing's underneath the radical. So don't lose the radical on there. Rad 6 over rad 2 is really just rad 3. You can do that. That's valid. You could do this the long way, but that's the quickest way to get that one. The long way would be multiplying the top and the bottom by rad 2. If these numbers have common factors, then do it. Divide that way or simplify that way. You can do that. These have no common factors. You're going to have to do this sort of the messy way, which is to multiply the top and the bottom by rad 3. And again, the whole point is rad 3 times rad 3 is rad 9, which is really just 3. Rad 3 times rad 3 is just 3. You can write 3 on the bottom. Done. Rad 11 times rad 3, well, you know that's going to be rad 33. And there's your simplified answer. Done. Leave it.